All right, we are in lesson 11, section 2. We're moving all the way to chapter 11. We're almost to the end of the year. We're doing decimal forms of rational numbers. So remember that rational numbers are in the form of a over b, where they terminate like 1/2 terminates, or repeats like 1/3 repeats. Can you express rational numbers as decimals or fractions? So I like starting off here with 7/8. Yes, you can take your calculator and take 7 divided by 8, but if you didn't have a calculator, would you know how to write this as a decimal? You would take 8 and divide it into 7.000 and as many zeros as you would need. So since 8 cannot go into 7, does 8 go into 70? 8 times. 8 times 8 is 64. And we're going to drop down. 8 goes into 60. 7 times. 7 times 8 is 56. And 8 goes into 40. 5 times, and this is where it ends. So, one thing I always tell my students to discover is if I take 1/8, so I'm going to zoom in right here. If I take 1/8, that is 0.125. Well, we know 2/8 is the same thing as 1/4, which is 0.25. 3/8, if we did that with a calculator, 3 divided by 8 is 0.375. We know 4/8 is a half, which is 0.5. And I am writing it like this for a reason. 5/8 is 0.625. And where did I get that? Do y'all see a pattern here? 6/8 we know is 0.75. I'm going to write it as 750. 7/8 we just found out. 7/8 is 0.875. And 8/8 we know is 1. So do you see a little pattern that it's going up by 0.125 every time? It's always nice to look at math and discover patterns because those patterns are going to help you out eventually. If you start looking at math classes, hey, I need to discover all these patterns, you're going to have an easier time in math. All right, well, what about 2/3? You probably know what 2/3 is. It is a rational number. If you don't, you're going to have to divide it. And you'll see a pattern here. 3 cannot go into 2, but 3 can go into 20. And notice that I keep getting that. So we do call it 0.67 or 0.6 repeating. So you could write that as 2.6 repeating or 2.67, but I believe we prefer the repeating. I believe that's what the curriculum goes with. Let me check. Oh, actually the curriculum does just have it as 2.666, so it doesn't even show it as 67. It shows it as this with ... And you should know what that ... means. It means that it's going to continue to go in that pattern. All right, so that's moving fractions to decimals. Let's go ahead and look at decimals to fractions. Well, I know that this is tens, hundredths, so I can write this as 48/100. And all we have to do is reduce. I can reduce each by 4, and I get 12/25. But we do have a problem when we have repeaters. So I want to make sure that I teach you how to do these repeaters. I'm going to start with this one, and I'm going to write down what the repeaters mean. So anytime you see a repeater, you need a 9. 9 is a repeater. 0 is the non-repeaters. So for example, I know this is going to be a negative. On the bottom, because there is one number repeated, I'm going to take 9. Because there are 2 numbers that are not repeated, I'm going to make those 0, 0. All right, and then what I'm going to do is I'm going to take the whole number. So looking at the whole number, I just see 415. And I'm going to subtract, so I'll write this out, whole number without decimals, and I'm going to subtract the non-repeaters. So only 41 is not repeated. And when I subtract, 5 minus 1 is 4. You can carry, or you could just say that we do get 37. So I'm going to take 374 and put it over 900. Now, the negative came from the negative right there. And you do have to see if this can reduce, and you need to know your divisibility rules. So if it can reduce, reduce. And when I reduce, it looks like everything can reduce by, no, this just could reduce by 2. So when I reduce, I'm gonna have, I divide everything through by 2. And I know that I have 450 on the bottom, and it looks like I have 187 on the top, but remember that's going to be a negative 187 over 50. All right, let's try this example. This one I didn't start with because this one has all repeaters. So I know that this is going to be 999 on the bottom. And on the top, I'm going to have the whole number. And remember, we're subtracting the non-repeaters. Well, that's 0, so I'm going to have 342. So really the only thing I have to do here is reduce 342 over 999. And that can be reduced by, I have to figure this one out. I think it could be reduced by 9. And we get 38 over 111. All right, let's see if you guys can round. Round 0.482 repeating to the nearest thousandth. So we do have to review. If this is tens, hundreds, thousandths, the next number would be 4. So it looks like if I rounded this to the nearest thousandth, I would have 0.482 because it would not round up. It would not round up. The nearest hundredth, tens, hundredths, it doesn't look like that one would round up as well, but we would just only show 2 of the numbers. And looking at one more, if I round this one to the nearest tenth, tens, hundredths, I know I'm going to have 5.3. If I round it to the nearest unit, that is just this. This won't round up, so it's just going to be 5. All right, there's a little practice. You know what? I don't want to practice any of those. I'm going to make up my own practice problem, and we're going to practice that. Okay, what if I have this? This is a common number. What if I have 0.83 with that repeated? Let's talk about this again. In the fraction, because of the repeater, I'm going to have 1 9. Because of the 8, I'm going to have 1 0. I'm going to take the whole number 83 and subtract the non. 83 minus 8 is 75. So here's what we get, but we do have to reduce. I know 75 and 90 both can be reduced by 15, where I get 5 over 6. So try to remember that little trick. If you want a different way, there are plenty of other videos, and the book teaches a different way of doing this if you don't like my way. My way has a little bit more of a trick to it.